It's difficult to predict many things. For example, it's a challenge to accurately predict the weather. It's hard for weather forecasters to say at what time it will start snowing, or how much it will snow, and when it will stop. But have you ever heard a weather forecaster say that tonight darkness is predicted and tomorrow light is predicted? Probably not, because these things are easy to predict. In fact, it's possible to predict when the sun will rise and set, as well as when the moon will be full. During the next few minutes, we'll study some of the interesting characteristics of the sun, as well as some of the characteristics of the moon, and we'll explore the relationships between the moon, sun, and earth. You may know that for many years, people believed the earth was flat. Sailors believed that if they sailed far out to sea, they would eventually fall off the edge of the world. Because the earth is so big, it looks flat to us as well. But we know the earth is sphere-shaped or round. We know this is a fact from photographs taken in space by astronauts and satellites. But the earth is not a perfect sphere like a basketball or a tennis ball. Instead, Earth bulges slightly at the equator and flattens slightly at the poles. Earth is spinning at a speed of about 1,600 kilometers per hour at the equator. Because the Earth is so big, we don't feel this spinning motion. However, we can see the result of this spinning motion. You decide, what evidence do we have that the Earth is spinning? If you said night and day are evidence of Earth spinning, then you're right. Look closely at this toy spinning top. Notice that it spins around an imaginary line called an axis. The axis of the Earth runs from the North Pole to the South Pole. The spinning of the Earth on its axis is called rotation. It takes about 24 hours or one day to make one complete rotation. Have you ever gotten up early enough in the morning to see the sunrise? While it appears that the sun is moving, it's actually the Earth that's spinning in relation to the sun. As the Earth continues to rotate, it looks as if the sun rises higher and higher in the sky. As the Earth continues to rotate in late afternoon, the sun is lower in the sky. And during sunset, the Earth spins away from the sun, and the sun disappears below the horizon. Then where is the sun at night? At night, the sun is on the other side of the Earth, where it is day. As the Earth continues to spin, eventually the sun appears in the east at sunrise to begin a new day. Have you ever noticed that during the summer, you can stay outside and enjoy sunlight long after dinner? But in the winter, it grows dark in late afternoon. This is due to the fact that the amount of daylight is greater in the summer than in the winter. You decide, what causes variation in light in some parts of the world during the year? The answers lie in the fact that the Earth's axis is not straight up and down, but is tilted at 23½ degrees. Due to the fact that the Earth is tilted in relation to the sun, at different times of the year, the length of daylight varies. For example, when the North Pole is tilted away from the sun, the northern hemisphere experiences less daylight. But when the North Pole is tilted toward the sun, the northern hemisphere experiences more daylight. We just discussed how the Earth, rotating on its axis, is responsible for day and night. But what is responsible for the different seasons? The answer has to do with the tilt of the Earth and its revolution around the Sun. You decide. How long does it take the Earth to make a complete revolution around the Sun? It takes about 365 days, or a year, for the Earth to make one complete trip or revolution around the Sun. Because Earth is tilted on its axis, as it revolves around the Sun, different parts of the Earth receive varying amounts of light throughout the year. For example, this is the position of the Earth in June. Notice how the northern hemisphere is tilted toward the Sun. At this time, in the northern hemisphere, the days are long. June 20th or 21st is the summer solstice, the longest day of the year. It is also the day when the sun is the highest in the sky. As the summer goes on, the northern hemisphere begins to tilt slightly away from the sun, and the days shorten. September 22nd or 23rd is the autumnal equinox, which signifies equal amounts of day and night. This begins the fall season, during which the weather grows cooler and the amount of daylight decreases. You decide. What is the winter solstice? The winter solstice, which occurs on December 21st or 22nd in the northern hemisphere, is the shortest day of the year. In Vermont, for example, there are only about 8.5 hours of daylight and 15.5 hours of darkness. Further north in Fairbanks, Alaska, the sun is above the horizon for less than 2 hours. This decreased amount of sunlight cools the northern hemisphere, which brings on the winter season. But following the winter solstice, the days gradually grow longer as the northern hemisphere slowly tilts back toward the sun. March 20th or 21st is the vernal or spring equinox, at which point the amounts of daylight and darkness are equal. The earth begins to warm from the increased amount of sunlight, and the spring season arrives. There are many different objects in our solar system. You decide. What's the largest object in our solar system? The sun is by far the largest object in our solar system. In fact, the sun is over 1 million times larger than the earth. The sun is the central point in our solar system, about which all of the planets, including Earth and our moon, revolve. The relationship between the sun, Earth, and the moon is often referred to as the Sun-Earth-Moon system because they all interact with each other. For example, the force of attraction called gravity keeps the moon in orbit around the Earth, and the Earth in orbit around the sun. We already took a look at how the rotation of the Earth on its axis causes day and night, and how Earth revolving around the sun causes the seasons. But what happens when the moon revolves around the Earth? Let's take a closer look at that question. Have you ever been out on a clear night with the light of the moon illuminating the landscape? What is the source of the moon's light? The moon doesn't create its own light. Instead, it reflects the light from the sun. similar to the way this mirror reflects light from this flashlight. We can see the moon most easily at night, but sometimes you can see the moon in the daytime. Have you ever noticed that the moon may appear in different shapes? The moon itself is not really changing shape. Different sections of the moon are lit by the sun, thus reflecting different shapes back to us. These varying shapes are referred to as phases of the moon. The different phases of the moon are the result of the moon revolving around the earth. When the moon is between the earth and the sun, the lighted face of the moon is facing the sun, and the dark side is facing the earth. Therefore, in this phase of the moon, called a new moon, none of the moon is illuminated. But as the moon continues to revolve around the earth, more of it becomes visible. This process is called waxing. In a few days, the moon continues to wax until the first quarter moon appears. Then, several days later, it becomes a beautiful full moon, seen here. In a full moon, the earth is between the sun and the moon, allowing us to see the entire illuminated side of the moon. But the moon doesn't stay full for long. As it continues to revolve, more of it grows darker. This process is called waning. The phase seen here is a last quarter moon. As the days go by, it slowly disappears to become a new moon, starting the cycle all over again. It takes about 29 and a half days to make a complete cycle of all the moon phases. During the past few minutes, we've explored many of the relationships and interactions between the Earth, Sun, and Moon. We saw how the Earth's rotation on its axis causes day and night. We also explored how the amount of daylight and darkness varies throughout the year, causing different seasons. We took a brief look at some of the characteristics of the Moon and a more in-depth look at the different phases of the moon. So, the next time you look at a beautiful sunset, experience a change in seasons, or look up at the moon, think about some of the things we've talked about during the past few minutes. You just might view the Earth, Sun, and Moon a little differently.